Question 6. So in this question, we're given two binomial expansions, ax cubed plus b to the power of 8 and ax cubed plus b to the power of 10. And we're told that the coefficient of x to the 6 in this first expansion is 448, and the coefficient of x to the 6 in the second expansion is 2,880. And we're asked to find the values of a and b, where both a and b are positive. Well, we have two unknowns here, a and b, so we're going to need two equations to be able to find this. But first off, what does it mean? The coefficient of x to the 6 is 448. Basically, when we expand ax cubed plus b to the 8th, we're going to get a bunch of terms, and each term is going to have x to the power of something. The term with x to the power of 6 is going to be 448 times x to the 6. And in the second expansion, ax cubed plus b to the 10th, we're going to get a bunch of different terms, and the coefficient with x to the 6, the term with x to the 6 is going to be 2,880 x to the 6. So anyway, let's recall the formula for binomial expansion. A plus b to the power of n. In general, this is equal to a to the n plus n choose 1 a to the n minus 1 times b plus n choose 2 a to the n minus 2 times b squared, and so on, where basically the rth term is n choose r a to the n minus r b to the r, and this goes on all the way to b to the n. And r here, when I say rth term, this starts with r starts at 0 and goes all the way to n. So r ranges from 0 to n. So basically, this is the r equals 0 term. This is the r equals 1 term. This is the r equals 2 term, and so on. This is the r equals n term. So what we have to do is we have to find out what does r have to be in each of these expansions to get x to the power of 6. Okay, well, let's apply this logic with r expansions over here. So first, the first expansion, ax cubed plus b to the 8th. So the rth term over here is going to be n choose r, n is equal to 8 here, n is what we're raising the binomial to. So 8 choose r times ax cubed to the 8 minus r times b to the r. And now for us to get x to the 6, this ax cubed here has to be squared. If we have ax cubed in parentheses squared, this is going to be a squared times x to the 6. We multiply out the exponents. So we need the exponent here to be squared for us to get x to the 6. So basically, 8 minus r has to be 2. We need the exponent there to be 2, and therefore r equals to 6. So x to the 6 occurs at the r equals 6 term. And now let's do this with the second expansion. Same thing, ax cubed plus b to the 10th. So in the first expansion, we had n equals 8. Now we have n equals 10. N equals 10. But it's the same binomial inside the parentheses. So the rth term here is going to be 10 choose r ax cubed to the 10 minus r times b to the r. And what does r have to be? Well, same with the first expansion, the ax cubed term has to be squared. So this ax cubed has to be raised to the power of 2. So 10 minus r has to be equal to 2. So 10 minus r equals 2, and therefore r is equal to 8. So in the second expansion, the x to the 6th term occurs when r equals 8. So we know which terms we're dealing with. So let's see if we can simplify this. So first expansion, we had ax cubed plus b to the 8, and we found that the rth term, so our term here was 8 choose r ax cubed to the 8 minus r. So we had 8 choose r, ax cubed to the 8 minus r, b to the r, and we established that r equals 6. So this is going to be 8 choose 6, ax cubed to the 8 minus 6, which is just squared, b to the 6. What's 8 choose r? We can do this in the calculator. So if you go to option, go to the right, prob, we see n choose r. So 8 choose 6 is 28. So we have 28 times ax cubed squared. Well, that's going to be a squared times x to the 6. And then we have b to the 6. And I'm just going to rewrite this as 28 a squared b to the 6 times x to the 6. And we know that this is equal to 448 x to the 6. So this equals 448 x to the 6. And now we can create our first equation. If we cancel x to the 6 from both sides, we just have 28 a squared b to the 6 equals 448. Divide both sides by 28. A squared b to the 6 equals 448 over 26. Excuse me, over 28, which is 16. So we have our first equation for a and b. A squared b to the 6 equals 16. Now let's do the same with the second expansion, which I'll do here in red. ax cubed plus b to the power of 10. And the rth term here was 10 choose r, ax cubed to the 10 minus r, b to the r, and we established that r equals 8. Therefore, this term over here is going to be, I'll just continue down here. So 10 choose 8, ax cubed to the 10 minus 8, so squared, b to the 8. What's 10 choose 8? Let's go back to our calculator. 10 choose 8, 45. So this is 45 ax cubed squared. That's going to be a squared x to the 6, and then that times b to the 8. And this is equal to 45. I'll just rewrite this as 45a squared b to the 8 x to the 6. And we know that this is equal to 2880 x to the 6. So all of this is 2880 x to the 6. So we divide x to the 6 from both sides, and we can get our second equation. So 45a squared b to the 8 equals 2880. And now we can actually divide both sides by 45. A squared b to the 8 is equal to 2880 over 45, which is 64. All right, so we have our two equations. A squared b to the 6 equals 16. A squared b to the 8 equals 64. Now let's actually solve for a and b. I'm going to go on to a new page. So equation 1, a squared b to the 6 equals 16. Equation 2, a squared b to the 8 equals 64. Let's just double check. Yes. So how do we solve this? Well, what if we divide the second equation by the first equation? So equation 2 divided by equation 1, we can cancel out the a squareds. So then we can solve for b. A squared b to the 8 over a squared b to the 6 has to be equal to 64 over 16. A squareds cancel. So I just did this equation divided by that equation. So we have b to the 8 over b to the 6, which is just b squared. 64 over 16 is equal to 4. So b squared equals 4. Therefore, b would be plus or minus square root of 4, which is plus or minus 2. But we were told that a and b have to be strictly positive over here. A and b are strictly positive. So b has to be positive 2. Can't be negative 2. And now let's find a. Well, we can sub this into either equation. I'm going to sub into the first equation. So we have equation 1. A squared times 2 to the power of 6 equals 16. A squared, what's 2 to the 6? 2 to the 6 is 64. So we have A squared times 64 equals 16. Divide both sides by 64. A squared is 16 over 64. 16 over 64 is 1/4. So A squared is 1/4. A would be plus or minus the square root of 1/4. And the square root of 1/4 is 1/2. So if we do here quickly, square root of 1 over 4 is 1 over 2. So A is plus or minus 1 over 2, and A has to be positive as well. Therefore, A is positive 1/2. So there's our answer to question 6, which I'll write down here. A equals positive 1/2, B equals positive 2.